For the following function, find the maximum number of zeros the function can have, the maximum number of x-intercepts, and the maximum number of turning points that the graph of the function can have. And here we are given the function f of x is equal to 5x cubed plus 8x squared minus 2x plus 9. So to get us started, I want to begin by recalling that if a function f of x is a polynomial function of degree n, then we can make the following conclusions. We can conclude that f of x has at most n real zeros. So in other words, if f of x is a polynomial of degree n, then f of x can have at most n x-intercepts. So n real zeros and n x-intercepts are equivalent. Now again, if f of x is a polynomial of degree n, then our function can have at most n minus 1 turning points. So we're going to go ahead now and use these conclusions to help us determine the number of real zeros, aka x-intercepts, and the maximum number of turning points that this beautiful cubic function can have. So the first thing that we want to do here is identify what's the leading term. And I sort of gave it away already. I mentioned that this is a beautiful cubic function. So our leading term here, we say a sub n times x to the n is equal to 5 times x cubed. So we can see here that our degree is n equals 3. And we're ready to make the following conclusions. So we can say that therefore, f of x has at most 3 real zeros, which we now know is equivalent to 3 x-intercepts. Now, we can also use this to determine the maximum number of turning points. So again, keep in mind that we'll have n minus 1 turning points. So if n is 3, 3 minus 1 leaves us with 2. And we can conclude that, therefore, f of x has at most 2 turning points. So the turning points being our extrema. And there you have it. This is our beautiful final answer.